we've got a couple different things we are going to look at in today's notes. The first is the coordinate plane, the definition of a coordinate plane, as well as an ordered pair. We'll talk about how to plot points on the coordinate plane, how to write ordered pairs. We'll talk about the quadrants of the coordinate plane. And then we will briefly discuss domain and range today as well. So let's start with the definition of coordinate plane. The coordinate plane is a two-dimensional surface formed by two number lines. So we've been graphing on the number line, and we've done that a decent amount. Now we have two number lines. Those number lines are going to be formed, one horizontal. Horizontal means side to side. One of the number lines will be horizontal. That is called the x-axis. And the other number line is vertical, called the y-axis. So the coordinate plane will look like this. We have our horizontal axis, our horizontal number line. It looks like it always does, goes side to side, and we can label it. So we've got 0 right in the middle, 1, 2, 3, and then as I go to the left, -1, -2, -3. There's a number line. We're used to that. We usually, from the things we've done thus far, we just have that one number line. Now we have a second number line. It's vertical, up and down. It passes right through the 0. Mine doesn't hit it exactly, but it's close enough. There we go. And the y, as I go up, has 1, 2, 3, and as it goes down, -1, -2, -3. So we have two number lines, one horizontal, the x-axis, probably should label that as the x-axis, and our vertical axis is called the y-axis. An ordered pair is a composition of the x-coordinate and the y-coordinate, and it's always written in this form right here. An ordered pair is written in parentheses with the x value first, comma, and then the y value. A composition of the x-coordinate and the y-coordinate written in the form x, y should be in parentheses with a comma in between. Example 1, we are given a big coordinate plane here. Here is the x-axis right here. Let's label that as x. And this right here is the vertical, the y-axis. It plotted a bunch of points for us here. I'm going to make them just a little bit bigger so we can see them clearly. And we are asked to write each point as an ordered pair. So let's start with point A. Point A is this point right up here. An ordered pair, remember, we put it in parentheses with a comma in between. This point, we always write the x value first. So this point has an x value of 1, 2, 3, and a y value of 1, 2, 3, 4. So my x value is 3, and my y value is 4. Point B. B is this point over here. Notice the x value is again 3. And the y value, because I'm going down, the y value is going to be -4. C. C is over here. X value is 4. Y value is 3. Point D, notice I go over to an x of 3. My x is 3. My y, I don't go up or down at all. That y value is 0. So there's the first 4. I did A, B, C, and D. I want you to list the coordinates of E, F, G, H, and I'm adding one more. I is right here. So I want you to try those 5. You get E, F, G, H, I. I'll give you a minute or two, and then we'll regroup and talk about them. If you guys need more time, by all means, pause the video, let everybody finish up. But let's go ahead and talk about these. Point E is right here. Notice it's right on the y-axis. I didn't go left or right at all. It has an x value of 0. The y value is 3. F, x value is 4. Y, I went down 3, so 4, -3. G, the x, I'm going left. If I go left, my x value is negative. So -1, -2, -3, and up 4. -3, -4. I'm sorry, +4. I went up. -3, 4. H is the one I was looking at when I said negative. I go left 3 and down 4. -3, -4. Lots of 3s and 4s. I didn't put anywhere else. And finally, I. Notice it's right in the middle here. I don't go left or right, so my x coordinate is 0. And I don't go up or down. My y coordinate is also 0. That is the point 0, 0. That point 0, 0 is called the origin. 0, 0 is the origin. So example 1, they gave us points. They asked us to list out the coordinates of each point. Example 2, exactly the opposite. It gives us a coordinate plane, a Blake coordinate plane. It gives us the ordered pairs, and we are asked to plot the points. It starts with point Z. Point Z is at the point 5, -2. 5, -2. Remember, when I am writing an ordered pair, it is x comma y. Also remember that the x-axis is the horizontal one, the side-to-side one, and the vertical axis is y. So this, I need my x to be 5 and my y to be -2. So my x is 5 and my y is -2. That right there is point Z. The next point that's given is -3, -4. -3, -4. My x is -3. Because x is -3, I'm going left. So -3. My y value is -4, so down 4. There is point y. And so on. 0, 3. My x is 0. I'm not going side to side at all. My y is 3. -1, 2. X is -1. Y is +2. -6, 0. My x is -6. So on the x-axis, I need to go to -6. 6, -6. And my y is 0, so I'm not going up or down at all. That is point V. And finally 1, 5. 1 on the x, 5 on the y. So all of this is a review of things you should have learned in pre-algebra. Hopefully we are quickly getting reminded how to do this. Next thing we want to talk about is quadrants. The quadrants of the coordinate plane. Quadrant means 4, so we have 4 areas of the coordinate plane. We name them quadrant 1, 2, 3, and 4. Typically, we use Roman numerals to define the quadrants. Quadrant 1, quadrant 2, 2 eyes, 3 eyes is quadrant 3. IV is 4. I'm not going to complain if you call them quadrant 1, 2, 3, and 4 written like that, as long as you can identify them properly. Quadrant 1 is this area all up in here. Notice the x value is positive and the y value is positive. We always start in that quadrant, and then it goes counterclockwise. Quadrant 2 is over here with a negative x and a positive y. Quadrant 3 is this area down here. X and y are both negative. And quadrant 4 is over here with a positive x and a negative y. And we defined the origin before. The origin is this point right here. So example 3 is going to give us some points. It's going to write them as ordered pairs and ask us to name the quadrant to which each point belongs. Point M is at -4, 3. -4, 3. So I would go -4. I don't have to plot it exactly, but -4 is over here. +3 is up here. Notice that point is in quadrant 2. Again, you can write it as the Roman numeral 2 or just the number 2. I would accept either one. Point N. Point N is at -2, -1. That's in quadrant 3. Point Q is at 1, -5. That's in quadrant 4. And point R is at 72, 13. We're probably not going to plot 72, 13 exactly, but 72 means I go this way, and 13 means I go up. It's over here somewhere, so it's in quadrant 1. Biggest thing on this is remembering that quadrant 1 is the one in the top right, and then it goes counterclockwise from there. 1, 2, 3, 4. And then the last thing we're talking about today is we're going to talk through domain and range. We'll define them and take a look at a couple examples on how to find them. The domain is the set of x values. The set of x values belonging to a relation. And as you might guess, the range is the set of y values belonging to a relation. Same definition, big thing to remember, domain is x's, range is y's. We do have a couple rules on how we write domain and range. First of all, it's a set, so we use set notation. A set we write with these curly brackets. They look like that. So we're going to use curly brackets, and we're going to put commas in between all the numbers, and then we're going to close it with a curly bracket. To draw those curly brackets, you make an S and then a backwards S. Or the other one, we start with the backwards S and then make an S. Oh, that's a bad one. If you're struggling to do that, you can just give me one of these and that works. So we use the curly brackets, set notation. Also, we list them from least to greatest. And finally, we only list once. Only list each one once. So if x equals 2 is part of our domain, we put 2 in there, but we don't put 2, 2, 2, 2 if there's a bunch of 2's. We only put it in there once to show that it's part of the domain. So your domain might wind up looking something like this. The set 2, 4, 5, 7. We write them from least to greatest, and we only list one each once. So let's try one of these. We are given these ordered pairs. This is our relation, -4, 3, 7, 2, 6, 3, -4, 2. And we are asked to write the domain and range. Write the domain and range of that relation. Domain is the set of x values, so we're just looking at the x values, -4, 7, 6, and -4. We use set notation, so we use the curly brackets, and we list those from least to greatest. So the first one I'm going to put, the smallest x value is -4, comma. I have another -4. I don't list it twice. I just put it once to show that it's part of my domain. The next smallest x is 6. The next smallest x is 7. And now I have taken care of all of the x's. This means that my x values are -4, 6, and 7. And the range, we do the same thing, but we do it with the y values. My smallest y value is 2. I have another 2. I don't list it again. Next one's 3. I have another 3. I don't list it again. Last example, same thing. We are writing the domain and range, but this time we're given a graph instead of a list of points. Write the domain and range of the relation. It gave us a bunch of points. We do it the same way. You could list it all out as ordered pairs if you wanted and do it exactly like we did the last one. Our domain, we're going to list all the x's. So I'm going to start on the left and start going right until I see a point. So my first one's right here, which has an x value of 2. And then my next one is 3. My next x, both of these points have the same x value of 6. And this one has an x value of 7. The range, I do the same thing, but I'm thinking about the y values. I'm starting at the bottom and working my way up. So the smallest y value I see is this point right here, which is 2. This point has a y of 3. C has a point or a y value of 4. A has a y of 6. And E has a y of 7. And that is a wrap for today's notes.